So we're going to have a quick look at radians and what they are and why they're better than degrees and why they're more useful. So to look at radians properly, we want to draw out a circle, and let's have a look at what the values of degrees are in radians. So if we're going round this way, 0, 45 degrees, 90 degrees, 135, 180, all the way back round to 360 degrees. The number of degrees in a circle is 360, and the number of radians in a circle is 2 pi. Now you just have to split that 2 pi up into what degree it is. So the 180th of a degree in pi. So you need to convert from radians to degrees by doing 180 divided by pi, and to convert from degrees to radians, then you need to do pi divided by 180. So as long as you know what the pi equals 180 radians, then you should be able to convert between the two quite nicely. So 90 is half of 180, so 90 is half of pi in radians. 45 is a quarter of 180, so it's a quarter of pi. So one of the reasons radians is useful is because it makes a nicer formula for finding things out, like sectors and arc lengths on circles. So if we look at an arc length formula in degrees, so it's n degrees that we're taking for, so we're trying to find this r, and that's the formula for it in degrees. So what fraction of the circle this is, so n divided by 360 times by the circumference of the circle, so you're just getting a nice little ratio. In radians, obviously we don't use degrees, we use radians, so this n we measure in radians instead, and 360 we measure in radians, which is 2 pi. As you can see down at the bottom. So you then sub it in like that, and then the 2 pi's just cancel out, and that means that the length is just given by n degrees times r. So it's a lot nicer, you don't have to worry about the 360 and the 2 pi, and you just have to do the angle times the radius to get the length. For the sector of the circle, you do a similar sort of thing, so you're finding out what ratio of the circle you're using, so the angle divided by 360, and then times it by the area of the circle, which is pi r squared. See, 360 is 2 pi, which means the area is given by theta over 2 pi times pi r squared. The pi's cancel, and that means you've just got the angle divided by 2 times r squared. And these two equations for the length and the area in radians is a lot nicer than the ones where it's in degrees. So it's good to be able to work in radians and use them in this sort of way, because it makes things a lot simpler. Thank you for watching. If you've got any questions or you want to see a proper example of it, then just message me something specific and I'll try and go through it, or comment below.